My name is Ray Ryan. I'm here with Tim Donnelly, who will come up and join me sooner or later. And we're here to talk to you about the reactive workflows pattern that we introduced this time last year at this conference. So like last year, I'm going to tell you some lies. But unlike last year, it's mostly true. And the bits that are lies, I expect to be checked into master within a few weeks. So this is more like mostly truth and prophecy than just bald-faced lying. So what are we up to and why are we doing it? Both of our Android and iOS mobile clients, we found them collapsing under the weight of their own code, and we needed to take a step back and try to figure out an architecture that we could work toward to make life better so that everybody didn't quit. And we have a couple of kind of ideas of what makes up a successful architecture, things that have to be true if it was actually worth your time to try. The main one is, or the primary one, I guess, is immutability. I should be able to assume that anything that's going across an API boundary is effectively a value object. Callers and receivers should be assured that things aren't going to change behind their backs that they give out and that they receive. When you can't, the next tenet is when you can't be that, when you're a dynamic object, you should be a reactive dynamic object. I can push data in, but I can't pull it out. And that doesn't necessarily mean that I'm using a library like Rx. It pretty much means no getters, period. I can't read my own writing here. And then finally, we have kind of emergent properties that need to happen from a successful architecture. It's not enough to say that I want to separate UI and business concerns, but it needs to kind of happen naturally. The simple way, the path of least resistance to write features in my app is going to separate UI and business concerns. In fact, that's the pleasant way to go. And similarly, it's got to be compositionally friendly. If I can't build big features out of small features and huge features out of big features, then I shouldn't have even wasted anybody's time. So with that in mind, let's take a step back and let's look at kind of the shape of the forest, the overall system, before we start focusing in on the individual details of the kinds of trees in it. Our forest is fairly simple. There's kind of like three clumps of things, three species of trees: business objects, workflows, and containers. Where a business object is your kind of microservice of the app. It's the fundamental business object building block. It's the thing that's responsible for your CRUD operations: create, update, delete. The workflow, the meat of what we're here to talk about, this is where we model our UI. This is where we, in particular, put a lot of attention into how a user navigates through our app, and then we present it at higher layers as view objects. And then finally, a container, which is where we take the results of all of those systems and turn them into actual rendered views that the user can see and that they can touch, what they can interact with. So let's take that section by section. And before we start drilling in further, we are keeping all of these things in touch with each other through what is now the trendy unidirectional Redux style flow. Unidirectional gets talked about and is trendy because it works. Redux did a great thing, and that's why we're all trying to reinvent it. So let's talk first about the business objects. This is pretty much the same thing that I said a year ago, so I'm not going to go into a whole lot of detail on it, but just to keep us all on the same page. These are our kind of our fundamental business blocks. These are, again, kind of our CRUD systems. I've got setter methods on the one side that I can push value objects in. I've got observables on the other side so that I can be notified what the state of things are as it comes in there. And and again, being very careful to make sure that everything that goes across that boundary is an anonymous struct. My foo value and my bar value should have no more notion of identity or no more ability to change than a string or an integer. What I definitely don't have on here is anything resembling a getter, anything that I can pull things out of on demand. I spilled my water. I apologize to the next speaker. Even if you know that the value is there and you're certain that it's going to be cached and I should just be able to call get on it, don't do that. Don't confuse your clients by mixing idioms in one API boundary. And also, you're probably wrong, like we have been wrong about a couple of our core compile time only feature flag systems that now all of a sudden we want to serve from the server, and God, life is bad. You can actually take this one step further and refine this down to just kind of a pair of methods. So rather than having a whole bunch of discrete set this, set that, and set the other methods, you can make this into a more of an RPC-like approach where I've got, say, an operation object that I can make requests with, and I've got a single observable that will give me the complete state of the brick at any given moment. You don't lose any expressivity that way. You're already used to working with RPC systems as far as the input goes. On the output side, I can always map and map and map down to a subset of the data that I actually care about. As a consumer of the data, I can debounce if that's interesting to me. And as the implementer and maintainer of the brick, life has gotten a lot simpler if I've got one input and one output, and it fits in nicely into that unidirectional flow we talked about. So in terms of how to implement these things, there are libraries that make it easier, they should show up on the screen now. There we go. So we have our own SQLite from Square. We've got RX preferences and rooms as other kind of nice RX-friendly ways to deal with the file system. I'm sure most of the people in this room are using Retrofit already. I don't need to preach about that. What I don't list here is SQLite because that has actually merged now, as you probably learned at Alex Strong's talk yesterday. And you know, if Cache can use it in alpha, it's probably good enough for the rest of us. So that gives us our business objects. Let's get to the meat of the talk, and let's talk about the workflows. What's the state of these things there? How does one actually implement them instead of just putting up diagrams of them? So first, a few more diagrams. So the workflow's job is to kind of define the app, to break it down into individual screens. And the particular app that we have found ourselves writing over and over again for the last year and a half or so as we prototype this is tic-tac-toe. So our tic-tac-toe game looks something like this. I start off in the new screen where I'm going to prompt to get the names of the players. I'm going to spend some time actually playing and ticking X's and O's, which I keep calling X's and Y's in my code, and I have to go back and change all the Y's to O's. Eventually the game will end, or I'm going to try to quit the game, and then I can start again. So what I've drawn up there looks an awful lot like a CS101 state machine. And it's, of course, you know, doesn't take a stroke of genius to recognize that connection there. But it's also kind of high level. It leaves a whole lot unexpressed. Like, for example, when I'm playing the game, what does that node actually look like? What happens there? And one of the selling points of a state machine approach is that they're supposed to compose nicely. So could I make a state machine of that particular part of the game? Seems reasonable. You know, I start off and it's X's turn, and then it's O's turn, and then maybe X will win, and maybe O will win, or maybe we'll have a draw, or maybe somebody will quit, and this is insane. I'm modeling a tic-tac-toe game, and I've already got 6 discrete states. What happens when I have actual work to do? We give up on state machines, and we don't try anymore, until we got to modern languages like Kotlin and Swift that give us parameterized enums and sealed classes and that kind of a thing. Because if you look at it, what I really have there is kind of 2 states with variations on them. I'm playing the game, and that's parameterized by whether it's X's turn or O's turn, or the game is done, and it was either a victory for one of those players, or it was a draw, or somebody quit. And while we're starting to think about it in terms of these kind of terms, what else, other state can we capture here? What else kind of gives us a complete game? So I've got my symbol enum, the X or the O in the box, or the box hasn't been selected yet. I've got the ending state that I finished with. It was a victory, it was a draw, or somebody was a quitter. Yes, I know that that's not actually Kotlin. That's Pigeon Kotlin. It fits on slides. We'll have compilable Kotlin in a moment. And then continuing this, we've also got the events that can happen. Well, this is a very simple game. The events are, I would like a square, or I'm going to flip the board over. There's nothing else that can happen. And then finally, there's the state of the game itself, which here is a pretty simple thing. I can have a list of my symbols, which I promise to keep down to 3 by 3 for the board. A map of the players that are playing and what their symbol is, whose turn it is right now, and what's on the board at the moment. So this was trivial to express in Kotlin, and I think the reason that we and other people are actually finally talking about state machines and actually trying to apply them is that the language has finally caught up with the CS. If I wanted to build something like this in Objective-C, I wouldn't. I would just walk away from it. I can do it in Java, but I still got a lot of kind of visitor pattern, double dispatch, boilerplate to go through, and I always give up, and I have something funkier at the end. But Kotlin and Swift, they beg you to work this way. So now let's go into actual code. Here is, I hope you can all see this slide. I'll read it character by character for you. The workflow interface is a lot smaller than it was when we talked about it last year. It's got 3 methods, only 2 of which you care about. It's its current state, which is an observable of whatever S state type it is that you decided it needed to have. And it's got a single result type. So This lets us express stuff like a login flow, where the screens are the state is the various login screen models that you're going to go through, and the result is a string, your authorization token or something like that. But it's not about view models strictly. This is an interface, a reactive interface that models any process, anything that's a series of steps. And whether those series of steps are view models or something else doesn't really matter to this. And if you look at this and you think, gosh, it's looking an awful lot like actors from other systems, we've noticed that too, and it's starting to leak into the implementation. So how we actually implement our tic-tac-toe workflow, we've got, it's going to be a workflow whose states that it emits are the turn object that we looked at, and it's got that completed state, the quitter one type of stuff. There's the same event object that we had on there before, you tick square or you quit. But the way that we're going to actually receive those events is through a publish relay. That's going to be basically a simple little input port into our system. This is where events get pushed into. What's a relay? A relay is like a subject, except it doesn't screw you over. It's something that Jake put together. Like it says there, it's a subject that will never complete and will never error out, so your pipeline never collapses on you. It's very handy, and yes, it's in both RX1 and RX2. Our code is so big that we're still using RX Java 1 because nobody's had the energy to actually go through it and port it to RX Java 2. I envy all the rest of you. So anyway, our events are coming in. What about our states? How are those going to map? Well, we have two states, remember. We're either playing or we're done. In both of those states, we have this turn structure, the thing that describes the entire state of the game, the player lap and the board. And we're playing. The turn is sufficient information. The game is over. We have that turn, and we add to that an ending, the win, draw, or quit thing. And now how do we actually get them in? Let's look at more machinery. So just like we had a publish relay for the events to come in through, we have a behavior relay, like a behavior subject that holds on to its last value, thing for modeling properties, that's holding onto our states. But if you look closely and carefully, it's not a behavior relay of state, it's a behavior relay of single of state. This is the interesting part, and I'm going to talk really slowly and go line by line because it's kind of the punchline. This isn't a pipeline of states. This is a pipeline of promises, of futures, of what state I will go into eventually when I enter a particular state right now. Whenever you see single on this slide or any of the rest of the slides, read it as future, read it as promise. So I've got that behavior relay of what is the next promise that will eventually fire to tell me what state I will be in at some point. I'm going to turn that using switch map into a stream of actual states like I probably expected to have in the first place. I'm going to have a replay call there at the end of this chain to hold on to the last value, that the last state that I was in, so an early subscriber or a late subscriber will both be able to see what was happening when. And finally, in the middle is the subtle bit. We're going to use a do on next call, so that as a side effect of entering a new state, each time that happens, we're going to make a call to this next state method and get from it the next promise, the next thing that will eventually resolve into the state after this one, giving it the state that we're entering as part of its input. And the way this next state method works, let's just consider our cases. We're either entering the completed state, in which case, no big deal. We emit a never, which is I promise never to emit another state because the state machine is done now and you should all unsubscribe. Or we're playing. And the way we find our future for the playing state is that we go back to our events relay, that input pipe, and we map that. We take the first value of that, we effectively turn it into a single of event, and then we map that into a single of what is the state that should come out from receiving this event when we're in the state that we're in right now. So we're in the playing state, and if the event was a take square event, then we're going to calculate whether what happens when we take that thing and emit an observable of either play the game some more or we're done now. And if it was a quit event, then I'm going to, again, shut things down, and I'm going to record who the quitter was. Either way, in that case, the state machine is over. So, and now I have some underlying to emphasize the stuff that I just told you that would have been helpful if I'd put it up 30 seconds ago. But again, it's all about singles. It's all about thinking in terms of futures. So everybody's still with me? We're going to do one more round with this. This code is not rocket science. It's not hard to replicate across the app, but it's kind of a subtle few lines of boilerplate. And it's easy to make little mistakes, and the code reviews get tedious, and there's a lot of teaching that's going on. We got tired of rewriting it. In particular, Zach Klippenstein got tired of rewriting it, and so we put together for ourselves a library that we call Reactor, which we will maybe open source, probably, maybe, unless we don't, but we will. And if I port my workflow to Reactor, it winds up looking like this. That's what it looks like before we port. There's the port. A reactor takes three types. It's got the state that it's cycling through. It's got an explicit event type, the events that it's willing to accept, and it still has that I'm done now, here's my result type parameter, which we've been debating getting rid of, but it's still been really handy. Where we had a next state method, we now have an onReact method. We still get into the state that we're playing, but what we're returning from there is a single of reaction, not a single of promise of the state that we're going to go into, but a single of reaction is basically a union type, an OR type. We're either going to enter into a new state or we're going to finish with the completion type. That's what's going on there. And then Reactor also provides this tiny little DSL, which has operations like, what I would like to do is select events. I would like to hang around here and wait until I either receive a take square event or a quit event. And when that happens, if I get the take square event, I'm going to enter state and call the same take square method that we had before, or I'm going to finish with I completed as a quitter, and that's it. So this much code, that actually is our complete reactor. Our port is done. I don't have to be thinking about behavior relays and subject relays. I don't have to download Jake's library directly. I'll get it transitively. But it's not quite a workflow yet. A reactor is more of an engine that's really good for building workflows. To actually make the thing start and to run, I have to instantiate it. I call the magical as workflow extension to get it to implement the workflow interface. And to do that, I initialize it with the state that I want it to be in at the moment. So any reactor can be started from any of its legal states. And the only way to start it is to get it to present itself as a workflow. Because I have this flexibility of being able to start reactors in arbitrary states, I can also provide myself another factory method so that I can, say, resume a workflow at a state that I left off. Handy for testing and handy for other things, as we'll see in a moment. Okay, iChart is over for a slide. We go back to the pretty picture now. So this is our top-level state machine, which we can see now has at least one of its nodes implemented with something that looks like code, the play game workflow. But what about the rest of these things? How are we going to implement this workflow of workflows? We jump back into Reactor, and what that looks like, our higher level game app reactor is something like this. Our states are more interesting now. For each of those circles that was on our diagram, we have a state class. It's a new game we're playing, maybe we're quitting, the game is over. And the most interesting state on there is that second one, the playing state. Remember, we were happy to have parameterized states because they keep our graph from blowing up. Well, one of the bits of information that I can hang off of one of these parameterized states is the actual workflow that I'm delegating to when I'm entering into that node that would like to have another workflow to be contained within itself. Keep going through here. Our events, not terribly interesting. I can start a game. I can confirm that I'm quitting. I can quit the app, etc. And now let's look at our React method, the one and only method in a reactor and the interesting part. So the first thing that's changed from our last one is instead of jumping straight into select event, the thing that lets us choose from all of the events that we're receiving, we're going to switch on what kind of state that we're in right now. Our last workflow pretty much had one state that counted. I'm playing the game, I'm playing the game. Now we can be in one of those four squares, and depending on circles, depending on which circle I'm in, there's different events that actually make sense to me. I'm not going to walk through the entire thing because even with a tiny little four-state machine, there's some code going on, but we'll follow one interesting trail through it. If we're in the new game state and we receive the quit app event, okay, fine, we're going to end this workflow called unit. If we're going to finish with it, we have no value to pass out. Presumably the activity is running this workflow. We're going to call activity.finish from here. Or we're entering into that state of another workflow, the play game state, which I cannot enter. I can't create that unless I first create the workflow that it embodies, And I can't do that unless I've passed in the names of the players that are going to make the game go. So what do I do if I'm already in that playing state and I'm presumably delegating to that workflow? When I'm asked what state I want to enter into next, I map the result from that child workflow. I hang around and wait until its result fires, until it's done, and depending on how it ended, that's how I decide what state to go into next. I'm not thinking about my own events at all. I am completely delegating until the child is done, and he's either going to tell me that somebody quit, or he's going to tell me that the game was over and here's how it ended. And then finally, one more step on this journey. Yep, more underlining, excellently timed. So I'm in that playing state. I go from I finished it, maybe I'm quitting. I go into that do you really want to quit state. They either just confirm, yes, I really do want to quit, and once again, we say, okay, the game is over, the guy didn't want to finish it, or they said they want to continue playing, so I want to return to that playing state. But my playing workflow ended. I can't say playing workflow pick up because it resolved itself, I dereferenced it, it's been garbage collected. But that's fine, because I was able to keep a note of, in the preceding states, of what turn we were on when we thought about maybe quitting. I can re-enter the playing game state with a new instance of that workflow with the resume method that we created, pass in the turn that we were on we go. And that's it, that is composition. So now I've got a workflow of workflows. Each node in this workflow in the state machine actually corresponds to a Kotlin class. I've got actual event objects on all of the traces taking me from event to event. It's all pretty self-documenting and it's all pretty much running. The one thing I haven't talked about though is those business objects. How do I actually stitch those things in? Like suppose I had a game service that I want to be synchronizing this stuff. It shouldn't be hard to maybe add one more parameter to our game over state, the synchronization state of how's that working. And the code for that would look something like this. Forget about it. Go write your own code. It's a short presentation. It's not that hard. But one hint, reactor server calls return singles, which fit nicely into this world. So what we find ourselves in, pulling all the way back out to our highest level pretty picture, is that business objects and workflows all kind of meld together into these nice state machines, but we haven't quite turned them into view models, something that we can actually render in front of the user. I promised you view models, and let's actually get those in there. That's one more code screen. So just like I can build a workflow out of workflows, I can also remap the data that's coming out of those workflows, the states of those workflows, into view models. And you remember I told you that I was going to tell you some lies? These are the biggest lies right now. The actual view model system that we've set up in our production Android code is a little bit more complicated than this. The view model code that Tim has been prototyping on iOS is simpler than this. This is kind of a happy medium, and we'll wind up somewhere in between those two poles before long. So anyway, what we have in our kind of nearly platonic ideal for a screen model is a tuple. A screen is a tuple. There's the D type, which is the data that I'm going to use to actually render the view that's on my screen there. And there's the E type, the event handler that defines the specific types of events that I'm allowed to take back from this screen. Okay, I have a couple of handy type aliases, and any screen is a screen of star.star. So this is for things that can emit just arbitrary screens, and the container gets to decide how to render them. And I've got the screen workflow, which is a workflow that emits any screen. This is how we view model. This is how it happens. So jumping into code again, I had my play a game workflow. I had my game app workflow. I'm going to wrap the game app workflow in a game screens workflow that casts those individual states into view models that I can pass off to the container layer. So that's the only interesting bit is in there. And it pretty much comes down to if I'm in the playing state, which of course, which has a delegating workflow, I'm going to actually, when I'm asked what state I'm in, I'm going to return something that maps the state of that sub-workflow and take whatever state is hanging off of that at the moment and turn that into one of these screen objects and pass that sub-workflow back, or an aspect of it back, as the thing that can receive events when I'm in that sub-state. And otherwise, I'm just going to take one of my own screens and pop it into the screen, or one of my own states, and pop that into the screen object that's coming out the other side. So this is still a little bit wordy, but it's because what I've done is I've got a workflow of a workflow of a workflow, and then at the very top, I'm using my knowledge of what's in each of those layers to push those into screen objects. If I had done this workflow wrapping at each layer, if I had a playing screens workflow instead of working directly with that model state workflow, it would look something more like this, where if I'm in the playing state, then I'm going to pass out the screens for that sub-workflow and let them collect their own events, and I'm just going to wait until they're done. And otherwise, I'm in one of my top-level states, and I'll just wrap those up directly. I'm glossing over things, but this is close enough to true that I'm confident in putting it in front of you. And so with that, we've taken care of our business objects. We've taken care of our workflows. We still have to talk about the container and put the pretty pictures in front of the users. On the Android side, it's okay, come on, Tim. On the Android side, we're kind of tied into a legacy system that doesn't generalize very well. But my friend Tim has been porting this stuff to Swift on iOS. He's been working from green fields. And he's going to present the container model that he's come up with because it demos really well and the API is beautiful. I fully expect Android to adopt it. Tim Donnelly.
Thanks, Ray. Oh, it's really bright up here. Okay, so today we're going to talk about workflows in Swift. And yeah, the reason that I'm here at an Android conference talking about Swift is because we're behind Android, we're not shipping it yet, and so we're not having to port a bunch of code every time we make changes, so we can learn from the work that Ray's done and really get ahead of things when it comes to the UI infrastructure. But all the stuff we're showing here, there's no reason this can't come to Android as well. So this is the general shape of the workflow architecture. Our workflows generate models. Those models are turned into UI by the container down there at the bottom, and then the UI sends those events back to the workflow. And if we add some details, we can see there are multiple nested workflows, like Ray was just showing, and that our UI is composed of multiple nested view controllers. So I'll be focusing on the container and how it handles mapping from those models into the views that we actually put on screen. So jumping into the container, every time the workflow tree changes state, it emits a new screen model. So the container needs some way to turn that model into a live UI instance, and it does that by using a view registry. So the view registry is effectively a map from screen types to live view instances. And it looks something like this. So it's generic around a view type. And in iOS, most of our UIs are built with view controllers, so that's commonly what we use. But I'll show a demo at the end where you'll see that we can use view registries to provide different types of UI implementations if we want to. And the API is pretty simple. We can just call provide view, we pass it a screen model, and we get back a live view instance from the registry. But the first thing we have to do is tell the registry how to instantiate a view for a particular screen type. And that looks something like this. The registry has a register method. We pass it a screen type, and then we give it a factory closure that's responsible for instantiating a live view instance. And one important thing here is that the view registry is built to be recursive. That factory closure that you provide actually takes two parameters. The first is just the screen model, but the second is the view registry itself that gets passed back in, and so we can capture that within our view instances, and that lets us build recursive UIs that can actually host their own child screens. So let's see this in action. When we pass the screen model into the view registry, it goes ahead and passes both that screen model across and the view registry back into that view controller. And then if that screen model actually contains nested screens, you'll see that the view controller here can actually use that view registry it received to take those nested screens out of the model and turn those into their own live view instances, and then add those as children within the view hierarchy. And so this approach lets us build these nested recursive UI trees. We've got nested screens turning into nested UI implementations, which we need if we're going to build complicated apps. So that's how we build out our UI recursively. I want to walk through a couple of the pieces of infrastructure that we use today that actually use this approach. And one of the big challenges for us in UIKit, it's similar on Android, is that so many of the system APIs are built with sort of an imperative API. They're not used to this model push-only world. And so we have to build this mapping layer to make this work, because now workflows are in charge. We can't store a state in the UI tree with pushes and pops or any of those other operations. The workflows are always in charge. So mobile apps are full of backstacks. In iOS, this is a navigation controller, navigation bar on top, forward and backward through screens. And this is the API we use there. It's its own screen model, and it contains other screen models. So it has one single property for the current item, and that current item is the actual screen to display, a key we can use for deduping as we're doing the update cycle, and then a model to use for the navigation bar. And so stepping through the update cycle for this, let's say the first time our workflow emits a model, we get screen A. Great, we've never seen it before, we show it on the screen. Next time the workflow transition state emits a new view model, we get a screen B. We've never seen that before, so we get a push animation. After that, we get a model for screen C. Same thing, we've never seen it, so we do a push. And then for the next update, we actually get a model for screen B again. And we know that we've seen this before, so we can do a pop transition. And this approach lets us derive transitions while only requiring the workflows to think about what the current screen is instead of worrying about the transitions between them. And that's, again, where the key in that model came in, that you can differentiate in cases where you have duplicate screen types, things like that in your backstack. And then next up is our modal container. And like the backstack, this screen contains other screens. It always has a main screen. And it also has an optional modal screen. Now, our real modal infrastructure is a little bit more complicated than this, but for a demo, this is roughly the approach. So if the workflow emits a model that lacks a modal screen, we just show the main one. And on the next update, out of workflow land, if we get a modal, we'll just animate it on screen. Great. And then workflow transition state again, and that modal goes away. So we animate it out of view and remove it from the hierarchy. And then to wrap things up, I wanted to show a demo that I actually built with some of this architecture. And so I built a game of tic-tac-toe, because that's what we do at Square. It's pretty simple, but I think it shows some of the potential of this stuff. There's a video here. Hold, please. All right, so we have a main screen. When start game is selected, we show a game within a modal. This is all run with workflows. And so every time I make a move there, it's sending an event over to the workflow tree that's sending a new screen model, a complete encapsulation of the UI state down to the container, and that's inflated and updated on screen. So great, it's a really simple game. But remember that our workflows are entirely decoupled from our UI implementation here. So to prove this, I added an alternate UI implementation for the same game. And so this is the same game that I just showed, line for line. It hasn't changed because it has no knowledge of the UI. This time I added a command line interface to the same game. And an important point here is that both of these UIs are representing the exact same workflow tree. I can interact with the game from either side of the screen, and the results are displayed on both sides at the same time. So that's pretty fun. But then taking this one step further, if we have a stream of immutable models to power our UI, it sounds pretty handy if we're going to do debugging and testing and things like that. And so what if we could navigate backward through the entire history of our application's UI? So now I have a slider at the bottom that scrubs through the history of the current app session. Every UI state we've been in, we can just scrub back through. And I'm sure we could take this further. What if we could serialize our UI states or view them on another device or anything else? It's this whole other world of things that we can think about doing once we decouple our business logic and our UI side. That's really exciting, and we barely scratched the surface of this. This is an afternoon's worth of demo building. But it's been really fun. And those are workflows. Thanks, everyone.